Okay, so we're supposed to solve a trig equation again here, and you might recognize this equation. It's the same one that we cracked in a previous example using a graphical approach. But graphical approaches are for wimps. Real mathematicians do things algebraically. So let's see if we can solve this just using algebra. They give us, let's start it off over here, 2 sine squared x equals 1 minus sine x. I'm going to suppress the trig functions just for a moment to make it a little clearer what this equation looks like. Instead of sine x, I'm just going to write s. So with the signs suppressed, this looks like 2s squared equals 1 minus s. You can see that's a quadratic, and we can make it look even more like a quadratic if we herd everything over to the left-hand side and obtain 2s squared plus s minus 1 equals 0. I've got it in descending order, the way a polynomial is supposed to look. And this would get even better if we could factor it. Let's see if we're clever enough to do that today. So 2 sets of brackets. I'm not going to do decomposition on this. The numbers are so small that I'm just going to kind of trial and error until I trip over the solution. We'll probably need 2s times s to give us the 2s squared. We'll need 1 times 1. And this middle term is supposed to come out positive, so let's see, 2s squared plus 2s minus 1s. Yep, that gives us the right total there. And negative 1 times 1 gives us negative 1. So if we split this apart, we can get a couple solutions for s. We get 2s minus 1 equals 0, which means s is 1/2. Or we get s plus 1 equals 0, which leads to s equals negative 1. Now remember, s is standing in for sine x, so what this is really telling us is either sine x equals 1/2 or sine x equals negative 1. Now, in the previous unit, we saw how to solve expressions like this. These are what we call first-degree trig equations. I'll do this kind of fast because you've already got some experience with it. Sine x is positive 1/2, so we have to be in one of the top two quadrants where sine is positive. Sine is opposite over hypotenuse, so we're either looking at 1 over 2 like this or 1 over 2 like this. I recognize that triangle. It's the 30-60 triangle. And so we have 30-degree reference angles there and there. That means our actual solutions here are 30 degrees, or 180 minus 30 is 150 degrees. And I just noticed they want us to speak radians, so when I say 30, I mean pi by 6. And when I say 150, I mean 5 pi by 6. There's those two solutions. And then, totally separate equation, if sine x is negative 1, that means our y is negative 1. Where are we if y is all the way down to negative 1? We have to be here. Our y goes 0, 1, 0, negative 1, 0. This is the only place where negative 1 occurs, and that would mean x is 270 degrees, or 3 pi by 2. And you will recall these are the exact same solutions that we got when we did this graphically on the previous page. So this unit is about solving second-degree trig equations. And how do you solve a second-degree trig equation? Well, you don't. What you do is you factor it, tear it apart into a bunch of first-degree trig equations, and then solve those. So if you can factor this, then great, you can carry on. If you're not able to factor this, then you're kind of stuck. Then this thing may not actually have solutions. And the general solutions which they ask for after this, you find the same way as in the previous question. You take each of these solutions, and then you put plus 2n pi afterwards. And as in the previous example, there is a way to compact all those solutions down into a single expression, because it happens that they're all evenly spaced. All of these solutions are 2 pi by 3 apart from each other. But the main part we want you to get is to get general solutions, add 2n pi, the period of your trig equation, to each of the solutions in the first 0 to 2 pi.